Alright, in this video we're going to discuss how to construct a scatter plot in Microsoft Excel, how to find the linear regression equation or trend line, and how to calculate the R value or correlation coefficient. And then we'll also talk about how to interpret the linear regression equation and how to interpret the correlation coefficient. Okay? And so, for the purpose of this example, just suppose I'm interested in knowing if the number of hours that you spend studying, what kind of effect does that have on a, suppose an grade on an exam, okay? So I have number of hours spent studying, and then I have grade on an exam. All right, so I'm just gonna make this a little bit wider so I can see it, and grade on an exam. All right, and in real life, if I'm interested in knowing this, this relationship, I would need to go out and ask people, hey, how long did you study for, and what grade did you get on your exam, right? But for the purpose of this example, I'm just gonna go ahead and make up some data that appears like it could be somewhat realistic. So, someone could study anywhere from probably 0 to 10 hours on a test for a single test, right? So I'm just kind of making up some data here. I'll go ahead and make up, looks like I have 15 observations, right? So notice that these numbers over here start at 1. So if 1 is where you have your variable names, then if you want 15 observations, you have to go all the way to 16, right? And when I highlight this data, down here, you'll see count. That's telling me how many observations there are, okay? A grade on exam. Now, when I think about the grade, I want to think about how many hours they spent studying, right? Someone who spent 2 hours studying, may have gotten 80%, but someone who spent 5 hours studying probably did a little better, right? But this is like random data, so it's not like this person with 2 hours studying has the exact same grade as that person with 2 hours studying, right? And of course, in real life, you would collect this data by asking people what they got, and you would record their data. But I'm just making up some somewhat realistic, potentially, grades here, okay? So let me go ahead and just continue to fill this out. Suppose this person is 95, this person has a 97, and a 91, and a 94, or 94, okay? Okay, so this is my made up data, okay? Now that I have my data, next thing I want to do is go ahead and make that scatter plot. So highlight your data. Okay, so I'm highlighting just the data here. So I just pressed on my left click and held it until I highlighted all of my data, and then I let go. Okay, and then go up here to insert, and right here where you see charts, we want this little chart here. So I press on that, and then it gives me several scatter chart options. This is the one I want. Okay, so just the one without any lines. I don't want any of these lines. Okay, so just that guy. All right, once you're here, go ahead and label your axes. I think it's really important to always label your axes, okay? So what's going to be on the Y and what's on the X? Well, naturally, Excel will think that whatever you've listed in column B, that's what's on Y, and whatever you listed in column A is what's on X. But also this makes sense because what grade you get on the exam depends on how many hours you spent studying, right? So our dependent variable, or Y, is grade on the exam. The number of hours that you spent studying is our independent variable, X. Okay? So go ahead and highlight the axes, and then go up here to, Format, or Chart Design. So Chart Design, add Chart Element, and Axes, and we want to do a title, axes title. So I want to do the vertical first. All right. Once you click on this, can kind of delete it and then write what you want. So grade on exam. Okay. Go back here, highlight or click on your chart again, chart element, axes, title, and then do a vertical or horizontal. Okay. Double click on this and write number of hours spent studying, and then chart title, let's go ahead and name it hours studying versus grade on exam. Okay, I can just close that. Okay, all right, so there we go. I have my scatter chart. And I can see with my scatter chart that, this desired effect that I was, I made up this data, so of course I'm seeing what I would hope to see, which is that the number of hours you spend studying, the more you study, the higher your grade, the less you study, the lower your grade. That's, what I would expect, okay? So once you have your scatter chart, we want to go ahead and just click on one of these points and then right click, and we want to press add trend line. Okay. Automatically, you're going to have the linear trend line, so that's great. Scroll down, and what I want to do is I want to display the equation on the chart, and I want to display r squared on the chart. All right, once you have those things, go ahead and just exit that. Okay. Now Excel will always put this in somewhere that's really inconvenient for you to read it. So if you click on it and get your cursor to look like that cross, the cross, and you can kind of move it around somewhere where you can actually see it. All right. So here we go. This is my linear regression equation. Right? How do I interpret that? Okay. So two things that I want to point out in this equation. First, note that it is a linear equation. So that means we have, y. So remember from high school, I'm going to go ahead and, let's see, I'm going to make this a little bit smaller so that I have somewhere that I can write that you can see it. Let me move this around. So remember from high school math, y equals mx plus b, right? Where m is our slope and b is our y-intercept, right? This is high school math equation of a linear line. So we see that we have a linear line here where m, in this situation, m is 4.6136, and our b-intercept, b, which is our intercept, is 60.833, right? So we need to interpret both of those, okay, when we're interpreting our linear regression line. So first, how do we interpret our slope? Our slope means that for every time we go up, however much our slope is, so rise, then we run 1. So if we go up 4.6136, then we run 1, right? So our grade increases by 4.6136 every time that we then increase our hours of spent studying by 1, right? So let me go ahead and write that down. For every additional hour spent studying, our grade on the exam increases, or it's not necessarily our grade, but the expected grade, right? So this line, it kind of averages over all these observed values. So it's our expected grade on the exam increases by whatever our slope is, by 4.6136. Okay. Let me make this so that you guys can see it all together. So I'm going to merge those and wrap it and move it down like that so that way you can see me interpreting the slope. Okay, so that's the interpretation of the slope. Now what about the interpretation of B, or y-intercept, which is in this case 60.8333, or 833, okay? Well, the y-intercept is whatever the value of y is when x is 0. So when you've been studying for 0 hours, it's your expected value of your grade. So let's write that down. We expect someone that studies for 0 hours to earn a 60 on the exam. Earn a grade of 60 on the exam, right? So let me go ahead and do the same thing. I'm going to wrap that. Okay, just kind of making this so that you guys can see it. Okay, there we go. So we expect someone that studies for 0 hours to earn a grade of 60 on the exam. And we can see this, that's where our trend line hits the y-axis, around 60. It's actually 60.833, right? So I shouldn't round that to 60, because if anything, it rounds to 61, not 60. Okay, so that's how you interpret your linear regression line. Now, there's one additional way that you can interpret your linear regression line. Sometimes students may want to interpret their line by finding a predicted value. So basically, a predicted, say I want to study for my exam 6 hours, and I want to predict what my grade will be if I study for 6 hours. Okay, so you can use this line to find that as well. So, predicted based off of, let me go ahead and move this down a little bit more. So, predict y based on a value of x. Okay, so that's another way that you can interpret your linear regression line. So to do that, if we wanted to do that, we would need to, so let me go ahead and move this over a little bit. So let's pick a value of x. So say I want to plug in 6 hours. So I would type in equals, okay, I'm going to do a calculation now, and I'm going to plug this in, 4.6136. Oops, let me just delete that. 4.6136, okay, times x, okay, x right now is whatever I'm trying to predict, 6 hours, suppose, plus 60.833. Okay, so that's my predicted grade, right? And so what we would have to write this out in a sentence in order for it to be an interpretation. So we would say we expect someone that studies for 6 hours, right, because that's the value of x that I plugged in, to earn a grade of 88.5146. Okay? And I'm going to go ahead and wrap that and make it so that you guys can see it. Okay. So there's 3 different interpretations for this same line, right? Okay, now what about R? What about our correlation coefficient R? Now we see R squared here. Okay, R squared was provided to us by Excel, but Excel did not automatically provide us with R. So what am I going to do? Well, if I have the squared value, so I'm told that R squared, okay, I'm going to go ahead and put it right here. I have 0.6588. That's my R squared value, right? I just copied it directly from right here. So what do you think R is? Oops, R. Let me delete that, okay. R. R then would just be equal to the square root, SQRT, of whatever you have for R. 0.6588. Press enter, and there you go, that's R. Another way that you could find R is by using the equation equals CORREL, C-O-R-R-E-L, okay? You can click on that, and then you'll be brought to the equation, or the formula in Excel. And it wants two things. It wants something called array 1 and array 2. So array 1 is just whatever your x's are. So you can click and then hold your clicker and drag down so you've highlighted all of your x data, but don't highlight too much, just your x data. Once you have it all highlighted, notice it's saying the formula, it's both here and it's down here, right? So this is the formula bar, which is exactly what's in the cell here. And it's saying A2 to A16, okay? Those are cell references. A2, there's a colon, to A16, so that's perfect, okay? Then write a comma, and that moves you on to array 2. So we want to do the same thing. Highlight our data and drag it down, all right? And then let go, and we see we're being from B2, right? B2, and there's a colon until we get to B16. Close parentheses, and then press enter, and there's our correlation coefficient. Okay, so there's two things that you need to consider when you're thinking about your correlation coefficient. First is the strength and the direction. Okay, so our correlation coefficient tells us these two things. So strength means that if we're near 1 or -1, then we have a strong correlation. Right? Which means that the number of hours you spend studying is a very good predictor of what grade you get. Strong correlation. Okay? If you are near 0, right? Either positive or negative, but if you're near 0, then you have the weak correlation. All right, direction. Direction is either positive or negative. All right? Now, you can look here and you can say this is positive because the slope is positive. If the slope was negative, then we would have negative direction. And this R value would also need to be negative. Okay? So if you use the square root method, that's always going to give you a positive number because the square root of any number is positive. So you would have to change it to a negative by just kind of putting your cursor here and then writing a little negative sign, right? And then it'll tell you negative. Only do that if your slope is negative. If your slope is not negative, then don't do that, right? This CORREL formula will give you positive, or it'll give you the correct answer. You don't have to worry about the direction, right? So positive, what does positive mean? As x increases, y increases. Okay, so as your number of hours studying increases, so does your grade on the exam. If you had something negative, that means as x increases, y decreases. Okay, so how would we interpret this correlation coefficient? That's pretty close to 1, positive 1. So, and it's positive. So I would interpret this by saying there is a relatively strong positive correlation between number of hours studying and exam grade. And then I would say something along the lines of, as the number of hours spent studying increases, we expect the exam grade to increase. Okay? So this would be your interpretation for your correlation coefficient R.